Yes. Okay, so page 39, we are going to talk about linear functions. So in the center of your journal, and center your page 39, you're going to write linear functions. And then we are going to make it into 4 sections so we can write things about linear functions. Okay, so the first thing will be the definition, top left. Second one is characteristics. And then we'll have examples and non-examples. Okay, so starting with definition. So you should have, over on page 31, definition of a linear function. So everybody look at page 31. And this was from our Quizlet that we had the definitions. It's right behind the divider, unit divider. Okay, so linear function. Oscar, what did you have?
Function whose graph is a line is a linear function. You can represent a line form with a line equation. I don't know.
Okay, so definitely it has a line, right? Okay, so the graph will be a line with a constant rate of change. And then we have some characteristics. So one of those characteristics is it's going to be a straight line. And then it's going to have a constant rate of change. It's going to be a 2-variable equation. And the 2 different forms that it'll be in, and you'll remember this from last year, y equals mx plus b. That's the most common form. And then there's also what's called a standard form, ax plus by equals c. So that's your standard form. So there's 2 different forms that it can be converted into. As long as it's a 2-variable equation. And then the last thing, x will have an exponent of 1. So it's the first degree. So even though I don't have an exponent here or here, it's an understood 1 being there. Okay, so then we'll talk about examples and non-examples. So an example, we'll do a little graph. So an example could be, I'm going to draw a line. Like that. You can use your ruler. If it's graphed and you have the same constant rate, see how this is going up 2 over 1, up 2 over 1, up 2 over 1. That's a constant rate. And if you draw a line there, that's a linear function. Okay, so this is what a linear function graph will look like. It can go any which way. It can have any kind of slant as long as it's a straight line. And then we have some examples of the equations. Let's say it's 3x plus 5y equals 2. Or we could say y equals 6, x minus 1. Or it could be y equals 3 over 5x. As long as x has an exponent of 1. Each one of these, x has an exponent of 1. Okay, and then the next thing is dealing with a table of values. So let's make a table of values. Table of values has x on the left, y is on the right. And we have values. So let's say 336, 630, and then 1218. Okay, so in order to show that it has a constant rate of change, we can check out how much it's increasing or decreasing for each x value. So let's go from 3 to 6. How much did it increase or
3.
decrease? That's 3. What about from here to here?
6.
That's 6. So we have the x's. Now let's look at the y's. Went from 36 to 30. Minus 6. And then 30 to 18. Minus 12. So in order to say that it has the same rate of change, we do delta y over delta x, which the delta means how much did it change by. The triangle is delta, but it means how much did it change by. So let's look at the first change. Delta y is negative 6 over 3. And then the other one is negative 12 over 6. How do we know if they're the same rate? What do we need to do? Divide it, simplify it. Okay, so negative 6 divided by 3, what does that equal? Negative 2. And what about negative 12 over 6? -2. So they have the same rate. Do y'all remember what the constant rate is also called in linear?
The end.
The m, the slope, yeah. So slopes are equal. So that means it is a linear function. Okay, so we have some good examples there. So now let's do the non-examples. So we'll start out with a graph. What could we put as a non-example for a graph?
Curve line.
A curved line of some sort? Yeah. Let's do a little U up here with arrows. So that's not linear, but we're going to learn about that this year. It's called quadratic. What else? What did we have on our function notation practice worksheet? That curve thing like that? It's non-linear because it has that curve in it.
Circle.
What? A scatter plot? And then a circle, yep. Let's say like that. So that's not a function. And then let's do a little circle. So these are all non-linear. Okay, and then equations that are non-examples. Let's say y equals, remember we have to have an exponent of 1. So a non-example would have an exponent greater than 1 or less than 1. So y equals x squared plus 6. That's non-linear. Or y equals 3. Let's make the exponent an x.
Okay.
And then, or if we have y equals 1 over x. Or if I have 3x to the third plus 5y equals 2. Because that exponent is 3, it doesn't work.
So if it has an exponent anywhere.
If the exponent of x is bigger than 1 or smaller than 1,
What if it has just like exponent on take 2?
then it is not linear.
So I mean like the exponent's not on x, but it's on like 2.
Oh, that's fine. As long as your x has a exponent of 1. Y can't have an exponent of greater than 1 either. Okay, let's do a table where it shows not a constant rate. X, Y. We'll do 2, 9, 3, 5, and 7, 21. So let's find our rate of change, constant rate. So 9 to 5. What is that? Minus 4. 5 to 21. Plus 16, yeah. Okay, and then we'll do our x's. 2 to 3. Plus 1. 3 to 7. So we need to find if they're the same constant rate. So we need to do change of y over change in x. So we'll do the first going from this set to this set.
5.
What is it?
9 over 5.
9 to 5, which was -4. That was how much it changed by. Over, how much did it change from 2 to 3? 1. Positive 1.
Oh.
And then what about the other one? From 5 to 21, change of y.
16.
16 over 4, because it changed by 4. We need to see if these are the same, so we need to divide them or simplify it. -4 over 1. -4. 16 over 4. 4. Are they the same?
No.
No. Slopes are different. Does y'all remember the word slope? Because we did it over here. Slopes are equal. Slopes are different here. Okay, so this is characteristics of a linear function. Okay, so I'm going to hand out a paper, and y'all are going to sort linear versus nonlinear. So you're going to draw this on page 40. Zoom out. And you're going to sort linear versus nonlinear.